All right, question number 8. Question number 8 says a sequence of figures is made up of unit squares with unit sides. The first three figures in the sequence are shown below. A. A says, um, draw figure 4 of the sequence in the space provided. All right, so let's test our artistic ability. All right, maybe it's satellite. Best to do it satellite by building. All right. All right, so we're gonna have 3 to the right, 1, 2, 3 to the right, 3 to the left, 1, 2, 3. We're going to have 3 up, 3 above, 1, 2, 3, and 3 below, 1, 2, 3. All right, more or less that is the fourth shape. All right. So if you examine it, from the first diagram is just one square. Then you put the second diagram, you put one square on each side of the first square. The third diagram, you put two square on each side of the first square. So the fourth diagram is you're going to put three squares on each side of the first diagram. All right, so more or less that's it. It could have been neater. If you wanted to be very neat, you could do the thing using what measurements and a ruler. But more or less, that is the fourth diagram. All right, let's have a go at the rest of the question. Now, the B part of the question says we're to what? Study the pattern of numbers in each row of the table below. Each row relates to one of the figure in the sequence. Some rows have not been included in the table. We're asked to complete the rows marked I, and IV. All right, so we're asked to complete those rows. All right. Um, Essentially, from this is what I've observed about the columns. All right, in this column here, the numbers in this column, the second column, the middle column, the numbers are increasing by you get to the next number by adding 4. In the last column, you get to the next number by adding what? Sorry. Is it by adding? No. What did I observe? You add 8. Is it 8? You get to the next number by adding 8. So in this one, so in the first column, you get to the next number. To move from one number in the sequence to the next number in the sequence, you add 4. In the second column, you add 8. So it means that over here, the format is 8 t 8 tn plus some unknown d. That's for the column over the right, and for the column in the middle, it is 4 tn plus some unknown, which is what? D. So whenever you have a sequence of numbers, which is increasing by a fixed amount, or a sequence in which the numbers are increasing by a fixed amount, it's always in this format. The format here and the format here. 8 is the number by which the sequence is increased, and D is somewhat constant. All right. Tn is just simply the term. So, for example, now for the very first term, it's going to be what? 8 times 1, because the first term is 1, plus minus 4, and that will give you the 4. The second one would be 8 times 2 minus 4, and that will give you 12. The next one will be 8 times 3 minus 4, and that gives you 24. Over here, over the left hand side for the middle column, in the first one, Tn is 1, so it's 4 times 1. 4 times 1 is 4. What do you do to that to get 1? You must subtract 3. So over here, D is 3. So over here, what we have is what? 4 times 1 minus 3, and that gives you 1. Then 4 times 2 minus 3, that gives you 5. And 4 times 3 minus 3, that gives you what? 9. So whenever you have a sequence in which terms in the sequence are, the sequence is advancing by a fixed number, it is always in this format. Over here to be 8 Tn. Tn is each term plus some unknown D. Over here it will be 4 Tn plus some unknown D. All right. And over the right hand side, D is minus 4. Over the left hand side, D is minus 3. All right, so remove this here. So now that we have a fairly good grasp of the sequence, we can try to get the other answers. All right, so the middle one is going to be 4 times 4, which is what? 16 minus 3. So that would be 13, or simply just increase by 4. So this is 13. Over here, you just increase by 8, because it's going up by 8. That would be 28. And also we can test it, because this line is actually supposed to be 8 times 4 minus 4. 8 times 4 is 32. 32 minus 4, that gives you 28. Over here, it's supposed to be 4 times 4 minus 3. 4 times 4 is 16. 16 minus 3, that is what? 13. So you could get it simply in the middle here by just simply adding what? 4. Over here by adding what? By adding 8. Or you could use the sort of like formula for each term, which is here and here. All right. And here. All right. Let's see if we can get this one here now. All right, over here in the middle here we have 45, and we need to find out what is the value here, the value to put here, and the value to put to the left, and the value to put to the right. Here's what we know. So let's find out what term number will give us 45. All right, let's sort of erase to sort of create some space. Remember, the formula for the middle is actually what the formula for the middle is 4 times Tn minus 3, and that this formula will give you the value in the middle. So if the value in the middle is what? 45, T is the term number. So let's find out what is the term number. So 4 Tn would be 45 plus 3. 45 plus 3 is 48. So 4 Tn is equal to what? 48. Divide both sides by 4. We get Tn would be equal to 12. So the term, this is a 12 term that gives a middle value of what? 45. Over here it would simply be what? 8 times 12 minus 4. 8 times 12 is what? 96. 96 minus 4. The value here would be 92. All right. In the middle, it is in the middle, this is going to be 4 times 30 minus 3. So that's 120 minus 3. 120 minus 3 is 117. That's in the middle. And in the n, over the n, it's going to be 8 times 30 minus 4. So 8 times 30 is what? 240 minus 4, that's 236. All right. So to get the middle value, you're going to multiply the term number by 4 and then minus 3. So here, this is going to be 4n minus 3. And over to the right hand side, it's going to be 8n minus 4. All right. So that would be the end of question number 8. So to recap, I will just remind you that if it is that if a number is increasing, if a sequence is increasing by a fixed amount, that the general format for that sequence is going to be, in this case, over to the right hand side, it's 8 times tn plus some unknown, which is d. 8 would be the amount by which the thing is increasing. It's going up by 8 every single time. All right, and d is an unknown. Most times, if you just look at the first term, you'll know exactly what to put for d. So in the first term here, it's going to be 8 times 1. Remember, tn is 1 in this line. In the first line, tn is 1. So it's 8 times t times 1 minus 4. That gives you what? 4. So d must be minus 4. All right, so there's something to remember. I'm quite sure it can come in very handy. Okay, let's have a look at question number 9. Question number 9 is the first question in section B of the paper. And in question number 9a, we're told that the table below shows pairs of values of x and y, where y is inversely proportional to x. I says express y in terms of x and a constant k. K is called a constant of variation. All right, we should remember that if y is inversely proportional to x, that the variation statement y is inversely proportional to x can be represented by the variation equation y is equal to k over x. So the variation statement y is inversely proportional to x can be represented by the variation equation y is equal to k divided by x, where k is called a constant of variation. II asks us to calculate the value of k. To calculate the value of k, we need corresponding values of x and y. So, for example, when x is equal to 3, y is equal to 2. We got that from the table, so we're going to put that in the equation. And the equation is y is equal to k over x. Therefore, y, which is 2, is equal to k over x, which is 3. If I have one fraction is equal to one fraction, what I would do is I would cross multiply. 1 times k is k, is equal to 3 times 2, which is 6. So k is equal to 6. All right, let's have a look at the last part of the question. In the last part of the question, we're asked to determine the value, the values of A and B. All right, so this is a variation question, and most variation questions of this form has a four-step flow. The first step is, you step one, you convert the variation statement into the variation equation, which we have done. Step two, you have to calculate the value of what? K, given a corresponding value, given a pair of corresponding values of x and y, which we have done. K is equal to 6. The third step is to rewrite the equation and put in this new value for k. So when you rewrite the equation, you're going to get y is equal to k, which is what? 6 over x. That's step 3. And step 4, you're going to be given a value of what? X to calculate what? Y, or a value of y to calculate x. All right, so let's just check back very quickly. When x is a, when x is a, y is 12. So let's go back to our question. So I'm going to just make that statement. When x is a, y is 12. So I'm going to put that information in my equation. So now I have y, which is 12, is equal to 6 over x, which is what? A. If I have one fraction is equal to one fraction, what I do is I cross multiply. So 12 times a is what? 12a. 1 times 6 is 6. Then I'm going to divide both sides by 12. So here a is equal to a half. Now to calculate the value of b, I'm going to go back to the same equation. Y is equal to 6 over x. And I'm going to say when x is equal to, let's go back again. When x is equal to 20, y is equal to b. So it's when x is equal to 20, y is equal to b. Let's put that information into our equation. We're going to have what? B is equal to 6 over 20. 2 into this is 3. 2 into this is 10. Therefore, b would be equal to 3 over 10. All right. So a is equal to a half. A is equal to a half. And b is equal to 3 over 10. Question number 9, part B. It says the diagram below shows the graph of the function f of x is equal to x squared minus 6x plus 8 for values of x from 0 to 6. So the domain value, or the x values which are used in constructing this graph, is from 0 to 6. All right, the first thing we're asked to do is to use the graph to solve the equation x squared. Use the graph to solve the equation x squared minus 6x plus 8 is equal to 0. All right, this is what I told you. If you're using graph to solve an equation, you must draw the graph of the left-hand side of the equation. So this is the left-hand side. So you need to draw the graph. Y is equal to x squared minus 6x plus 8. And you need to draw the graph of the right-hand side of the equation. And over there, you have y is equal to 0. And the solution would be the value of x where the two graphs intersect. Let's say that again. If you are asked to use graph to solve an equation, you must draw the graph of the left-hand side of the equation and draw the graph of the right-hand side of the equation. The solution of the equation will be the value or values of x at the point or points of intersection of the two graphs. All right. Now, the beauty about it is that both of these graphs have already been drawn. The parabola, which is the curve, is the graph y is equal to x squared minus 6x plus 8. And the x-axis is the line y is equal to 0. The solution is the value of x where the two graphs intersect. The two graphs intersect here and here, where the values of x are 2 and 4. So the solution of the equation, the solutions of the equations are x is equal to 2 and x is equal to 4. Next, we're asked to write down the coordinates of the minimum point in the form xy. All right, this is the minimum point on the graph. That's a minimum turning point, and the x value here is x is equal to 3, and the y value down here, this is y is equal to minus 1. So the coordinates of the minimum point are x, which is 3, and y, which is minus 1. All right. The third part of the question says write x squared minus 6x plus 8 in the form a into x plus h squared plus what k, where a, h, and k are constants. All right. We could do this using sort of a formula approach, or we could use um, an approach which I believe the examiner intended here, which is based on understanding. All right. Now h in this formula, h x is equal to minus h is the equation of the axis of symmetry. All right. And the equation of the axis of symmetry is x is equal to 3. So this is minus h. Therefore, x, which is equal to minus h, is equal to 3. X is equal to 3 is the line of symmetry. The line of symmetry is the vertical line that passes through the turning point. And the vertical line through the turning point is x is equal to 3. Therefore, h is equal to minus 3. Um, x, y is equal to k is the minimum value of y. Therefore, y is equal to k, which is equal to minus 1, is the minimum value of y. Therefore, x squared minus 6x plus 8 would be equal to a, which is 1. So it's 1 into what? X plus h. H is minus 3 squared plus k, which is what? Minus 1. So we have just basically completed what the examiner asked us to do. As I said, we could have done this using a formula approach, but since we had a graph of the function, we didn't need to use the formula. We could use our understanding of what? Of the graph and completing the square in order to come up with the solution. Let's look at the B part of the question. It says on the same axes, draw the graph, draw the graph of the straight line g of x is equal to x minus 2. So let's write the defining equation of this function. The defining equation is equal to x minus 2. Alright, so y is equal to x minus 2 is a y is equal to x minus 2 is a linear function, and the graph of a linear function is a straight line. Remember, we basically only need 2 points in order to draw a straight line graph. So I'm just going to select two arbitrary values of x. I'm going to say, and remember the range of values of x I have are between 0 and 6. So I'm going to say when x is equal to 2, I'm going to get y is equal to 2 minus 2, which is 0. So 2, 0 is the coordinate of 1 point on the line. Remember, to draw a straight line graph, I need at least 2 points. 3 points would be ideal, but 2 is good enough. Same equation, y is equal to x minus 2. I'm going to select a second point. My second point would be I'm going to say when, let's just say x is equal to 4. Y would be equal to 4 minus 2, which is 2. So the next point is 4, 2. Alright. And everybody should remember from coordinate geometry, for the equation y is equal to x minus 2, that minus 2 is the y-intercept. It means that the graph cuts the y-axis at minus 2. So let's go back to the graph and draw a graph. Alright, so I believe that the points we got to draw a graph are, I think we had 2, 0, we had 4, 2, and we have that the y-intercept is minus 2. Alright, so 2, 0, x is 2, and y is 0 is this point here. So y is 0, and x is 2. X is equal to 2, y is 0, that's that point. The next point is 4, 2, x is 4, y is 2. So that's this level here, y is 2. So that is this point. Alright. And the final point, which we really didn't need, the final point would be the y-intercept. Alright. And the y-intercept is minus 2. The y-intercept is minus 2. And essentially that means that the graph must cut the y-axis at minus 2. Alright, so let's draw a graph. So you need a ruler, because remember that this is a straight line graph. You line up all your points with your ruler, your straight edge. Alright, and draw your line. I'm using freehand, but you must not do this. You must use a ruler. Alright, so this is the line y is equal to x minus 2. Alright, here's something that I believe is going to be important for us to note. It's going to be important let us note exactly where the two lines intersect. The two graphs intersect here, where x is equal to 5, and here where x is equal to 2. So the graph of y is equal to x squared minus 6x plus 8, and the graph y is equal to x squared x minus 2 intersect at x is equal to 2 and x is equal to 5. So what we just did was to draw the line y is equal to x minus 2 is the solution to part IV of the question. Now we're at the last part. To hence solve the equation x squared minus 6x plus 8 is equal to x minus 2. Earlier I said this and I'm going to say it again. If you're using graph to solve an equation, you must draw the graph of the left-hand side of the equation. So on the left-hand side, we have y is equal to x squared minus 6x plus 8. And we must also draw the graph of the right-hand side of the equation. On the right-hand side, we have y is equal to x minus 2. And the solution of the equation would be the value or values of x at the point of intersection, or the points of intersection of the two graphs. Remember, we already noted it, that the two graphs intersect. So my solution, the two graphs intersect where x is equal to 2 and where x is equal to 5. So x is equal to 2 and x is equal to 5 are the solutions of the quadratic equation x squared minus 6x plus 8 is equal to x minus 2. Question number 10a. It says the diagram below, not drawn to scale, shows a circle with center O. The vertices H, J, K, L of a quadrilateral lie on the circumference of the circle, and the P, K, M is tangent to the circle at K. The measure of angle HJL is 20 degrees, and angle JKH is what? 50 degrees. All right. So this topic is circle theorem and quadrilateral H and the quadrilateral HJKL is a cyclic quadrilateral because all the vertices lie on the circumference of the circle. We're asked to calculate, given reasons for each step of your answer, the measure of angle HKL. So let's identify that angle HKL. So this is the angle we're being asked to calculate. Now angle HKL is actually equal to 20 degrees. So there's no nothing to calculate, it's just 20 degrees. And the reason for that is that there are what angles in the same segment. There are angles in the same segment. All right. So this is from circle theorem, and this is just a basic thing about angles in the same segment. Essentially, they have the same starting point and the same end point on the circumference. So this one goes up to the circumference. The angle there is 20 degrees from the same point. So they have the same start point and the same end point. This one goes from here to over here, the circumference, and then come back to the same point. This angle, both this angle and this angle, they're 20 degrees. Both of those angles, they're 20 degrees, and they're called angles. They're called angles in the same segment. All right. So let's move on. Next, we're asked to calculate angle JOK. Angle JOK. So let's go back to our diagram. Angle JOK. All right, angle JOK. Let's identify it. Angle JOK There's the angle here at the center. All right. All right, angle JOK. Let's call it something. Let's call it theta. All right, and let's see if we can determine the easiest way of arriving at the answer for that question. Well, I observe that OJ and OK are radii of a circle. Therefore, triangle JOK is an isosceles triangle. O would be the apex, and JK would be the base, and the two base angles of an isosceles triangle are equal. So if this is 50, this is also 50 here. So to answer the question about JOK, I'm going to say theta, which is JOK, plus 50 plus 50 degrees would be equal to 180 degrees. And they are the interior angles of an isosceles triangle. They're the interior angles of an isosceles triangle. So theta is actually equal to 180 minus 100 degrees. So theta, which is angle JOK, is equal to 80 degrees. Angle JOK is equal to 80 degrees. All right. Next, we are asked to find angle JHK. All right, let's go back to the diagram to identify angle JHK. All right, this is angle JHK. The angle here is what we want. Let's call it alpha. All right. All right, so quickly, theta here, this angle here is 80 degrees. All right, and now we're asked to find angle JHK. All right, angle JHK, which is alpha, is 40 degrees. Angle JHK is equal to 40 degrees, and I'll tell you why. The angle at the center, which is 80, is equal to 2 times the angle at the circumference. So the angle at the center is equal to 2 times the angle at the circumference. So angle at the center and angle at the circumference, they both start at the same point. Both of them start at J and end at K. One goes to the circumference, that is JHK goes to the circumference, and JOH goes to the center. So the angle at the center, which is 80 degrees, is 2 times the angle at the circumference. So angle JHK is 40 degrees. All right, so let's write that. Angle JHK is equal to 80 divided by 2, which is equal to 40 degrees. Why? The angle at the center is equal to 2 times angle at circumference. All right, question 10b. It says a ship travels from Akron A on a bearing of 30 degrees to Belleville B. It says which is 90 kilometers away. So the ship travels on a bearing of 30 degrees. So that angle here is 30 degrees. Let's try and put it in a little bit better. The angle here is 30 degrees. All right. If you want to write it properly, it's actually 030 degrees. All right. And the distance from A to K, A to B is 90 kilometers. All right. So it travels. All right, fine. It then travels to Compton C, which is 310 kilometers due east of Akron. So east is 90 degrees from north. So it is this length here, which is 310 kilometers. All right. Fine. As shown in the diagram below, indicate on the diagram the bearing 030 and the distance 90 kilometers and 310 kilometers. So I've already done that. Now we're asked to calculate to the nearest kilometer the distance between Belleville and Compton. All right. So essentially, what we have here is a non-right angle triangle, and for this non-right angle triangle, we know the length of two sides, and we know the inclusive angle. All right. Let's try and show all of that very clearly. So this angle here is 30 degrees. And the side here is 90 kilometers. Now the angle in here is 60 degrees. All right. Why? Because the entire angle, the angle between north and east, remember C is east of A. The angle between north and east is 90 degrees. So you take away 30 from 90, you get what? 60. Now, if you know two sides of we're asked to calculate to the nearest kilometer the distance between Belleville and Compton. All right, so I'm going to call that distance x. Now, if I know two sides of a non-right angle triangle and the size of the inclusive angle between them, to find the third side, I must use cosine rule. Cosine rule says a squared is equal to b squared plus c squared minus 2bc cosine a. In this formula, a is the side opposite the inclusive angle, so that's x squared. B and c are the two sides of known length, so this is 90 squared plus 310 squared minus 2 times 90 times 310 times the cosine of the inclusive angle. A is the inclusive angle, which is 60 degrees. All right, so I'm just going to put this in the calculator and press equal to find out what is x squared. All right, so I have 90 squared plus 310 squared minus 2 times 90 times 310 times the cosine of 60 degrees. All right, and then I press equal. So x squared is equal to 76,300. The opposite of square is square root. So x would be equal to the square root of 76,300. X, which is BC, is equal to 22,760 kilometers, 276 to the nearest kilometers. BC is equal to 276 to the nearest kilometer. All right, so next we're asked to calculate to the nearest degree the measure of angle ABC. We're asked to calculate to the nearest degree the measure of angle ABC. Let's identify the angle ABC. So this is the angle that we want to find. we can call it alpha. All right, that's the angle we want to find, angle ABC. All right, most times after you use the cosine rule, the rule that you're going to use next is the sine rule. Most time after you use the cosine rule, the rule you're going to use next is the sine rule. And the sine rule says the sine of an angle, which angle we want to find? Want to find alpha over. All right, let's write the sine rule first. Sine rule says sine A over the side is equal to sine B over B. So whenever I'm using the sine rule, I always start out with what I want. So what I want is alpha. So I'm going to say sine alpha over the side opposite from alpha. So we can go back and look quickly. The side opposite from alpha is 310. So it's over 310 is equal to sine 60 degrees over the side opposite to the 60 degrees is the 276. All right, so let's bring this up there. We're going to get sine alpha would be equal to 310 sine 60 divided by 276. All right, so sine alpha. All right, let's find the value of this to 3 decimal places. So that's 310 times the sine of 60 divided now by 276. All right, so what we got is 0.9727. Let's use 4 decimal places. So alpha would be equal to sine inverse 0.9727. Alpha, which is angle ABC, would be equal to 0.9727. Alpha would be equal to 77 degrees to the nearest degree. Alpha would be 77 degrees to the nearest degree. All right, so next we're asked to determine the bearing of Compton C from Bellevue B. All right, to determine the bearing of Compton C from Belleville B. All right, to do that, we need to at least go back and look at the diagram. So let's look at the diagram again. All right, so this is what we're being asked. We're asked to determine the bearing of Compton from Belleville. All right, bearing is measured clockwise from north. So we're doing the bearing from here. All right, we're measuring bearing from Belleville. All right, and bearing is measured clockwise from north. So I'll start from north. All right, and we'll go around from north to the line that connects. So essentially, that's the angle we need. We need this entire angle here. We know this part of it. This part is 90, and this is the part that we actually don't know. We need to know this, find out what this part is. this part of the angle here. We need to know that part of the angle. All right, maybe we should call it something. Let's call it something. Let's call it beta. So we know part of the angle. The bearing of C from B is this angle here. All right, part of the angle we know, and the part that we don't know we're calling beta. Once we find beta, basically, once we find beta, we'll be good. So again, the last part of this question asks us to determine the bearing of C from B. We already concluded that the angle we're looking for is this angle here. All right. Remember, we already determined that this angle. We already determined that this angle here is 77 degrees. Also, if you look carefully, you can see that this angle beta is the same as angle C. They're alternate angles. Angle beta is the same as angle C. So therefore, since we can find C, we can find beta. All right. So let's find angle C. So the angles we have within the triangle are 60 degrees, 77 degrees, and C. So let's find C. All right. So angle C, the angle at C would be equal to 180 minus 60 plus 77 degrees. So the angle here would be 180 minus 133. So the angle at C, which is equal to angle beta, is equal to 47 degrees. So the last part of the question, the bearing of C from B would be equal to 90 plus 47. The angle is 137 degrees. So the bearing of B from C, this entire angle here, remember bearing is measured clockwise from north, is 90 plus 47. This angle here is 137 degrees. All right. So lastly, we're going to look at question 11. In question 11, 11a, it says the matrix T, which is C009, maps the point P onto the point Q. So the matrix T, which is what C009, sorry, not 9D, D maps the point P, maps the point P, which is 2, 3, to Q, which is the point 2 minus 3. All right. So what you notice, all the matrix T did, or transformation T, all it did was simply change the sign of the x coordinate. Sorry, change the sign of the y coordinate. All right. So P, which is 2, 3, became P, which is 2, 3, under T became the point Q. So this is P, and it became Q, which is 2 minus 3. So again, all T did to P was simply change the sign of the x coordinate. The y coordinate remains the same. All right, so let's find out what the matrix T is. So the matrix T would be this matrix. All right, first of all, let's start off with the I matrix. Now, if you multiply a matrix by the I matrix, it remains the same. The top value, the top row affects the x coordinate, and the bottom row affects the y coordinate. And what we noticed is that what t did to p was simply change the coordinate, change the sign of the x coordinate. It means that the matrix T is this matrix here, with a -1 and a negative in front of the 1 in the bottom row. This is the matrix T, and if that be the case, it means therefore that C is equal to 1 and D is equal to -1. So the identity matrix, which is 1, 0, 0, 1, does nothing to a coordinate. If you apply that matrix to a coordinate, the coordinate comes out to be the same. The top row affects the x coordinate, the bottom row affects the y coordinate, and since the only thing that changed when you apply t to p was that the sign of the y coordinate changed, is to find out what t is, you simply put a negative in front of 1 on the bottom row. Now determine the image of minus 5, 4 on the t. All right, we're asked to determine the image of -4 determine the image of -5, 4 on the t. All right, so remember what t does to an all t does to a coordinate is to change the sign of the y coordinate. The x coordinate remains the same. That means that the point -5, 4 on the t is going to become the point -5. The x coordinate remains the same, -4. The sign of the y coordinate changes. Next, we're asked to describe fully transformation t. All right, first of all, which transformation keeps the x coordinate the same but changes the sign of the y coordinate? Which transformation keeps the x coordinate the same? Under t, the x coordinate remains the same, but the sign of the y coordinate change. Transformation does that is reflection in the x-axis. It means therefore that t is a reflection in the x-axis. T is a reflection in the x-axis. All right. Now let's have a look at this part of the question. It says find a matrix that maps the point Q back to P. What they're basically asking you to do is to find the inverse matrix. What they're basically asking you to do is to find the inverse matrix. Now, if you reflect P in the x-axis, you get Q. So the converse is also true, that if you reflect P, you get Q. So if you reflect Q in the same x-axis, you're going to get back P. All right. It means therefore that T is equal to T inverse, which is equal to 1, 0, 0, -1. All right. So it means therefore that Q, which is what's Q again? Q, which was 2 minus 3, which is 2 minus 3 under T inverse is going to become P, which is the x coordinate remains the same and the sign of the y coordinate changes. All right. So the inverse transformation that which is going to map back Q back to what P is the same transformation T. All right. So if you reflect something in the x-axis, if you reflect a point in the x-axis to get the image to get back the from the image to the object, you must reflect the image this time in the same x-axis to get back the object. All right. So the matrix you're looking for, T inverse, is the same as T, and it's 1, 0, 0, minus 1. Okay, next we're going to look at 11b. It says the graph below shows 3 points P, Q, and R relative to the origin O. It says write as a column vector in the form xy the vector OP. All right, so the vector OP. All right, first of all, let's identify the vector OP. All right, this is the point P, and OP would be a position vector. And a position vector is a vector that is tied to the origin. All right, a position vector is a vector that is tied to the origin. All right, so this is the position vector OP. All right, all right. In column matrix form, the position vector OP. If you remember anything from position vector, the coordinate and the position vector is the same. So OP is the vector 4, you have to go 4 right, so that's 4 top, and 1 down, so that's minus 1. So P is the point 4, minus 1, and the position vector OP is the vector 4, minus 1. So the coordinate for position vector, the coordinate and the vectors are the coordinate and the vector is basically the same, or have the same values, the same numbers in it. All right, we need the vector. We need the column matrix for the vector, the column vector QR. The column vector QR. All right, this is QR. This is the vector QR. So let's get it from counting. To get from Q to R, you have to go what? 1, 2, 3 units to the right, and 1, 2, 3, 4, 5 units up. All right. So to get from Q to R, you have to go 3 units to the right and 5 units up. So therefore, the vector QR is the vector 3 right and 5 up. Is the vector 3, 5. All right. So QR is the vector 3, 5. So the vector QR is the vector 3, 5. All right. Now, so the next thing we're asked to do is to determine the magnitude of QR. So remember, QR is the vector 3, 5. The magnitude of vector QR would be the square root of 3 square plus 5 square. So that would be the square root of 3 3 is 9 plus 5 5 is 25. So this is the square root of 34. So the magnitude of it 30, and the square root of 34 is 5.83, and that's units. to 3 significant figure. 5.83 units to 3 significant figure. Next, we're asked to, and this is the absolute last part of the question. Yes. We're asked to what on the graph on page 33, draw the vector OS. It says show that the vector OX that looks like 7, 4. So the vector OS, and this looks like 7, 4. Show that PQ RS is a parallelogram. All right, so let's go back and put in the position vector OS. All right, so let's put in OS. OS is the position vector 7, 4. So the position vector and the coordinate is the same. So looks at the point 7, 4, 7, 4, 7 vertical, 4 horizontal is this point here. So this is the point that is the point S, and this would be the position vector OS. All right. So you should use rulers. I mean, I'm drawing freehand, but you should use ruler. So, and the very last thing, so we're putting the position vector OS. The very last thing we're asked to do is to show that this shape, here, I'm guessing PQRS, to show that PQRS is a parallelogram. To show that PQRS is a parallelogram. Basically, how do we show that? That a shape is a parallelogram? To demonstrate that a shape is a parallelogram, you have got to show that vectors on opposite side of the parallelogram are equal. You have to show that the vectors on opposite sides of the parallelogram are equal. We already determined the vector QR. Let us now determine the vector PS. We already determined the vector QR. Vector QR is 3, 5. Let us now determine the vector PS. Now, if those two vectors are equal, it means that these two sides of the shape of the quadrilateral PQRS, that opposite sides of the quadrilateral PQRS would have the same magnitude and are parallel. And if opposite sides of a quadrilateral have the same length and they're parallel, that quadrilateral is a parallelogram. All right. So let us use calculation this time to determine PS. We didn't have to, but let us do it anyway. All right. So if we're using calculation, I mean, I would say something like this, that PS would be equal to PO plus OS. All right. PO, I think PO was OP was 4 minus 1. So PO would be minus 4 minus 1. All right. So PO and OP are inverse vectors. So they're the same magnitude but opposite direction. And the OS is the vector 7, 4. So what we're going to have here is minus 4 plus 7. And a negative times a negative is a positive, 1 plus 4. It means therefore that OS, that PS, so this is 3, 5. Therefore, PS is equal to QR, and they're both equal to 3, 5. All right. So if PS and what QR are equal vectors, two vectors are equal if they have the same magnitude and the same direction. The length of the line is a reflection of the magnitude. So that means that the line PS, the length of the line PS is the same as the length of the line QR. So the two sides of the quadrilateral have the same length, and line PS is parallel to the line QR. All right. So PS is parallel to the line QR. So here we have two lines that are both what equal and parallel, and they are on opposite sides of a quadrilateral. So quadrilateral um quadrilateral PQRS is a parallelogram. How do we show that PQRS is a parallelogram? We have to first show that that opposite sides, which is PQ and RS, that opposite sides, um, PQ and RS have the same length, they have the same magnitude, the same length, and the same direction, meaning that they're parallel. Once you show that opposite sides are equal and parallel, effectively you have shown that the shape is a parallelogram. All right, so that's the end of the test.